Welcome back. I think this is April 1st, and we are looking at section 8.5 in your textbook. So far, we have graphed quadratic equations in standard form. So they were ax squared plus bx plus c. Remember that we found the axis of symmetry by finding minus b over 2a. We found the vertex, that was the x-coordinate of the vertex. And we found the y-coordinate of the vertex by plugging in that value for the x-coordinate into that equation and define the y. The y-intercept, we could tell by inspection, was whatever that constant term was. In vertex form, we had the vertex axis of symmetry is where x equals h, and the vertex is at h, comma k. Today we're looking at graphing an equation that's in intercept form. These are easiest of all. It's already been factored, and that looked like a factored equation where the x-intercepts are p and q. Remember, x-intercepts is where that function crosses the x-axis. The axis of symmetry will be in the middle of those two roots or those two zeros, so we use the midpoint formula. That means we're going to add the p and the q together and divide by 2. You're just averaging the endpoints to find the middle. To graph, we're going to plot the x-intercepts, then we're going to find the axis of symmetry, plot that with a dotted line. Remember that when you've done that, that's the x-coordinate of the vertex, so the vertex is going to be on that dotted line. Then we find the y-coordinate of the vertex by plugging into this equation the value for the x-coordinate, so that would be p plus q over 2. Graph those points, connect them with a smooth line, and there we are. In your book, if you look at page 450, the core concept, it's what we just talked about. Remember, this is in intercept form, and the values that they give you are the intercepts of that equation. That means they're the roots if you had solved it algebraically. Look at example 1 on erasing. While you're looking at your book. Look at example 1 where we have negative x plus 1 and x minus 5 for our function. So f of x equals negative x plus 1 over x plus 5, x minus 5. Describe the domain and range. Well, what do we know about this parabola just by looking at that equation? Do we know whether it opens up or down? Yes, we do. Do we know what its intercepts are? Yes, we know those. So I'm going to have an intercept at negative 1 and positive 5. And that means I have an axis of symmetry. When I add those together and divide by 2, that's the first thing. So if we were plotting this, I would have negative 1 and positive 5. Negative 1, positive 5, that'd be the first thing we plot. We're going to calculate our axis of symmetry by adding those together and dividing by 2. So 4 divided by 2 is 2. Axis of symmetry, and remember that's also the x-coordinate of our vertex. Then we're going to plot and find that vertex. So to do that, this is the value that we're going to plug back into this equation. So I have negative 2 plus 1 and 2 minus 3. So I have negative 3 times negative 1. 2 negatives make a positive, so I've got a vertex at 2, comma 3. Then do 2 minus, I don't know where that 3 came from. 2 minus 5. Which is, I don't know this class. Let me start with this. It is very late. I'm still trying to do these and learning how to do them, so a little understanding. I have 2 plus 1 and 2 minus 5. There we go. There we go. So I have negative 3 over here, and now I have, I don't know where that is. I have 3 times 3, so negative, positive 9. Negative 9. So 2 comma 9. I'm plugging, I should just do this again, you know. We equals 2, and so we're plugging that back in, so I have 2 plus 1, and 2 minus 5, and I've got a negative sign out in front of that, so I have a negative 3, and another negative 3, so positive 9, and I've got a vertex at 2, 9, much better, so way up here, 2, 9, we have a vertex, and we would be connecting these, and so now we're ready to talk about domain and range. What do we know about the range? This is going to be a maximum because this is opening down, and so my range is y is less than or equal to 9. And what do we know about domain? It's a quadratic equation, so the domain is the set of all real numbers. If you look at example number 2, and you're describing your domain and range for that one, and f of x equals 2x squared minus 8. It's not in this format, so we want to put it in this format. So intercept format means we're factoring. So I'm factoring out a 2, and I'm left with x squared minus 4. We recognize that as a difference of 2 squares. So 2 times x minus 2 and x plus 2. What does that mean about our graph? I've got intercepts at 2 and at negative 2. I know my vertex is going to be right in the middle. So I've got intercepts at 2 and negative 2, and I add those together and divide by 2, and I'm at 0. So this y-axis is our axis to symmetry. X equals 0, that's the equation for the y-axis. To find out what our y-coordinate of that vertex is, we know it's going to be on 0, and we're plugging that in, so I have 0 minus 8, so it's 0, comma negative 8 is my vertex. What does that tell us about domain and range? Domain is the set of all reals, that's always true. And the range, this is an opening up parabola, so this is going to be a minimum. So y is greater than or equal to negative 8. Piece of cake so far, right? If I look at monitoring progress, look at those, graph them, and let's see what the domain and range are for those. If I'm looking at number 1, and you've graphed it, you should have negative 2 comma 0 for 1, and 3 comma 0 for your other x-intercept. That means when you're looking at them, the x-coordinate of the vertex is 1/2, and the vertex, or that's the axis of symmetry, x equals 1/2, and the vertex is 1/2. I'm going to plug 1/2 back into that equation and end up with negative 6 1/4. What do I know about the domain? Set of all reals. What do you know about the range? Is this an opening up parabola or an opening down? Look at the equation. There's no leading negative, so this is a parabola that opens up, and this is a minimum, so y is greater than or equal to negative 6 1/4. If I'm looking at the second one, giving you the answers, I would appreciate it if you paused and calculated them yourself. But I don't have a way of enforcing that since we're doing it with video, so just try. And negative 2, excuse me, and I have x minus 4 and x plus 1. Remember, these are your x-intercepts, so you're going to average them to find the axis of symmetry. When you do that, you're going to end up, so I've got negative 1 comma 0 is one x-intercept, and 4 comma 0 is the other one. I'm averaging 4 and negative 1 together, so when you divide by 2, that's 3/2, and I have an axis of symmetry at 3/2. That means I've got a vertex at 3/2, and we're going to plug 3/2 into this to see what our corresponding y would be. And when you do that, it's 12.5. Check your arithmetic. 12.5. What do you know about domain and range? Domain is the set of all reals, and the range, this is an opening up or an opening down. This is negative, so it's opening down, so this is a maximum, so y has to be less than or equal to 12 1/2. There is one more there's one more, so look at number 3. Did we do 2? We did 3. This is 2 or 3. Telling you, it is very late. So I'm looking at number 2. This was 4 and 1. So negative 2, positive 2. I feel like I already, that was example. Never mind. I am so sorry. Example 3. This one, 12 and a half. That's where we were. Looking at example 3. Not example 3. Monitoring progress 3. Where you have h of x equals 4x squared minus 36. It's not in that format, so you're going to factor and put it there. So you're pulling out the 4, that's the GCF. And then we with x squared minus 9. Again, that's a difference of 2 squares. So we factor it, x minus 3, x plus 3, and that means we've got zeros at 3 and negative 3. And that means we've got an axis of symmetry when x equals 0. Plug that back into that equation, and our vertex is going to be 0, negative 36. Does this open up or down? Opens up, so this is a minimum, and y is going to be greater than or equal to negative 36, and the range is the set of all reals. So remember, when we're talking about these, functions have zeros. And that's where that value of that variable that makes that function equal to 0. The graph of that function has x-intercepts. And the equation that represents that function has roots or solutions, and they're all describing the same number. So when it says use the intercepts to find the zeros of the function, I'm in example 3 in your book, so look at that. Find the zeros of f of x, and they're already giving it to you in factored form. What could be easier than that? X minus 1, x plus 2. That's like saying this is 0 when x minus 1 times x plus 2 produces that 0 anytime I've got 2 numbers multiplied together that equals 0. That can only happen if the first one is 0. That means x would be 1. Or when the second one is 0, and that means x is negative 2. So when x is 1 or negative 2, those are the zeros. That means if you graphed it, those are the points where that parabola would be crossing the x-axis. If you turn the page and look at the example number 4, you're finding the zeros for the equation that's given f of x equals negative 2x squared minus 10x minus 12. It's asking you to find the zeros. So what are you going to do first? Always pull out the negative and the GCF. So in this case, we're pulling out a negative 2, and that leaves us with x squared plus 5x plus 6. Remember, when you pull out the negative, all the signs inside must change to be equivalent. Then we're ready to factor that. So we have negative 2. I'm thinking factors of positive 6 that we can add together to get a 5. So I'm thinking x plus 2 and x plus 3. And so I have zeros at negative 2 and at x equals negative 3. So that's where it would be crossing the axis. If I'm looking at, there was another one, looking at B. This is why factoring, one of the reasons is so important. You will be doing it forever. For B, they already give it partially, in factored form. So I have x minus 1 for the first part, and then I have a difference of 2 squares, x minus 16 for the second factor. Obviously, this isn't going to be a quadratic equation because I've got not squared as my highest exponent, but 3. So this will be a cubic function. And if you remember back in the beginning, cubic functions sort of look like that. They're parent functions. Not that that matters, that's just for interest. So here we're gonna factor, I have x minus one, I've got x minus four, x plus four, because this is a difference of two squares, and that means you've got zeros when this is equal to zero. I have x equals positive one, x equals positive four, or x equals negative four. 3 roots for that one. If I'm looking at monitoring progress, this is time for you to do it. And check and see what you get. Monitoring progress for number 4, you should have zeros at 6 and 1. When x equals 6 and x equals 1. They gave it to you in factored form, so what could be easier than that? Then I'm looking at 5, so you're going to pull out that 3, and you're left with x squared. Pull out the 3, and you're left with x squared minus 4x plus 4. I'm thinking that's 3, x minus 2 squared. I have a double root. Remember we said that was multiplicity of 2? A double root when x equals 2. If we look at at 6, there was one. So that was 4, that was 5, multiplicity of 2, a double root. What does that mean when a parabola has a double root? So sometimes parabolas cross that x-axis at 2 places, so 2 roots, or sometimes it just touches and goes back, so I have 1 root, but we call that a double root, and sometimes when they don't factor, or they don't cross that x-axis, that's really what it is, then I have no real roots, and we will do more with that a little bit later. If I'm looking at example 5, where you're using the characteristics to graph and write, so I've got zeros to graph, and they give you some function, h of x equals x squared minus 2x minus 3. Well, if I'm going to graph, what do I already know? Parabola opens up because my leading coefficient is 1. I've got a y-intercept at negative 3. It's in standard form, so I could use minus b over 2a to do it, or I could factor it and find the midpoint that way. Since we are factoring, we'll go ahead and find the zero. So I have x minus 3, x plus 1, and set that equal to 0, so x is 3, and negative 1. So if we were graphing, I've got 1, 2, 3, there's a point. I've got negative 1, that's a point. That axis of symmetry is right in the middle, so when x equals 1, that's the axis of symmetry. And I have a vertex. I'm going to put 1 back in and see what we have. So I'll have a vertex at 1. We know it opens up, so somewhere opening up, and your book graphed it for you and found that you've got, when did they finish? We were finding where the zeros, sorry. And then graphing. So make a table of values and plot those other points. I would look at negative 3 being a constant term, so I know it's going to be there. I've got a vertex here somewhere over here. I've got another corresponding point, so the vertex is going to be lower than 3. And in fact, when you did it, it looks like it was at 4, which I would get when I plug 1 minus 7 negative 2. 1 minus 3 is negative 2. And 1 plus 1 is 2, so negative 4 down here would be that parabola. You know about domain and range? Domain is all a set of reals that opens up, so the range, y is greater than or equal to that negative 4. Not the last. Example 6, if we write quadratic functions given so things that we're looking at, it has to have a vertex, through some points. Negative 9 comma 0, negative 2 comma 0, and negative 4 comma 20. What do we know about these points? Those are the x-intercepts, and we've got a vertex at negative 3 comma 4, and that point's got to be on it. So look what they did. They start by using the vertex form. So a parentheses x minus h squared plus k, that's where we are. What am I going to be filling in? Well, h, the x coordinate is negative 3, so this is going to become plus 3. I've got a y coordinate of 4. So now I need to figure out what the a is, and I've got a couple of ways to do that. They took this in vertex form and multiplied them out, so I've got an x squared plus, where am I going? I don't know what the a is, if they're doing it this way. They left the a and they substituted a for 1. That was just to make it easier. Technically, you've got some work to do to find this, but following this example, they left that equal to 1, and we're going to square this, so you have x squared plus 6x plus 9 plus 4, so x squared plus 6x plus 13 would be that equation in standard form. Not technically, because they didn't do anything with the a, we'll save that for algebra 2. If we did it in the second case, where I'm given the intercept, so I'm going to use the intercept form, then we're going to work, whoops, I don't want to do that. Negative 9 comma 0, negative 2 comma 0, and 4 comma 20, is that right? Negative 9, negative 2, 4 comma 20, negative 4 comma 20. And I want to put, so this is the second part of this, b, that's passing through those points, and we're forgetting that we don't have a vertex. So we're not using the vertex form, we're using the intercept form. So if I know I'm intercepting, I have an x plus 9, and an x plus 2, and an a, and that's my f of x. So I've got intercepts, x-intercepts at negative 9 and negative 2, and I don't know what the a is yet, but I have an x and a y that are going to help us figure out the exact equation. And so now at this point, we're going to plug in for y. So remember, we could replace f of x with y. So 20 equals a times x plus 9. Sorry. My x is negative 4, so I have negative 4 plus 9 and negative 4 plus 2. So I started with vertex form, intercept form. I plugged in the intercepts from these values, and now we're using an x and a y so that we can figure out what the a is. So this will be a true parabola. So I have a times negative 4 plus 9 is 5, and negative 4 plus 2 is negative 2. So I have negative 10a equals 20, and when I solve for a, I find out that a is negative 2. So this equation is negative 2 times x plus 9 times x plus 2. I could leave it like that. If they want to put it back in standard form, then I'm foiling these and multiplying by 2, and you would be there. Which is what they did. If I'm using zeros to graph monitoring progress, this is one to pause. I'm going to put the answers on the board. I hope that you are figuring them out while you are paused. If I pause, it's just dead space, and that just takes more time. So pause, and then come back and look. So number 7, when you were checking, you would have had zeros at 1 and 4. And for 8, you would have zeros at negative 4 and 3. And for 9, you would have a quadratic equation that satisfied those points. Should be x minus 1 times x plus 1, and we know that looks like x squared minus 1 without even doing any work. Number 10, y was a times x minus 8 squared plus 8, and you're substituting in for y when you finished, and it should have been, your final one was x squared, they assume, minus 16x plus 72. For number 11, again, I hope you are doing these yourself. I'm plugging in 12 equals a times, where am I? 4 minus 0. I'm going to replace it with the x, and 4 minus 10, and then solving, so 12 equals a times 4 times negative 6, so a is negative 1/2, and that's, so then my equation is negative 1/2 times x minus, times x, because x minus 0 is x, and x minus 10. And for number 12, the last one of these, I know you're as good at as I am. For number 12, on monitoring progress, when you finish, you should have ended up with f of x equals 2x squared plus 2x minus 40. That brings us to using characteristics to graph and write cubic functions. All this means is instead of having 2 roots, I now have 3 roots, and it's going to be exactly the same. I'll just have one more multiplication to do. So look at example 7. Where you're given f of x equals x cubed minus 4x. I want to find those roots, and so we begin by factoring out an x, and then I'm left with x squared minus 4, and so I have x times x minus 2, x plus 2. And that means we've got zeros. Remember, a 0 is whatever value of those variables that make that function equal to 0. So we have zeros at x equals 0 for this one, or x equals positive 2 for that one, or x equals negative 2 for the last one. And that's what they're showing you to help determine the shape of the graph. Look, and so we will be doing a lot of this in Algebra 2, not so much in Algebra 1. All you need to do is look what the book did, table of values, your graphing. You can use your calculator to plot some of those points, and then or you trace it with a smooth curve. It helps if you know what a cubic function looks like. So remember, it's going to come, this is the parent function. It's going to come up, I'll have 3, the parent function is just x cubed. So it's got 3 zeros right at the origin, multiplicity of 3. As it gets out, I might cross once, twice, 3 times. That could be a cubic function. If I'm looking at example 8, here's a graph, and you're writing the function from the graph. So remember the intercepts. That's what you're looking for first. So if we're doing this from the graph, you're reading those intercepts. So right away, you know the equation is going to have some form that you don't know yet what the a is, but it's going to be x minus whatever those intercepts are. And so here I've got 1 at 0, so that's just an x. I have 1 at 2, so x minus 2. And we have a third one at 5, so x minus 5. To write the equation, I would probably FOIL these two first. So x squared minus 2x minus 5x is minus 7x plus 10. That gets multiplied by x and by a. Well, I would have put the a. Do I have another point? I have another point. Oh, so stop. I have another point. So our y value, so that would have been 12, and that equals a. Remember, we've got to figure out what that a is. It's going to produce this exact tons of equations go through these zeros. Only one would match this particular one in the graph, and so we have to find out what the a is. And so I have 12 for the y, and my other point was 3 for x, so I have 3 for x, and 3 minus 2 is 1, that's so nice, and 3 minus 5, and this is what I'd be multiplying together. So 3 times 1 times negative 2 is negative 6, and 12 divided by negative 6 is negative 2, so a is negative 2. Now we're ready to put our equation in. F of x equals negative 2 times those, and then you can FOIL, multiply by negative 2x, and there you are, and you have the one that they wrote, negative 2x cubed, etc., plus 14x squared minus 20x. Monitoring progress. Number 13, if you're using those zeros, you are plotting all 3 points, and then in a table of values, pick x, and plot a couple more, and then connect. You already know you're looking for how high it goes and how low it goes. That's in Algebra 2. I will be happy if you plot them and make a table of values and just see where it's going. If I'm looking for number 14, that one you're factoring. It's a cubic equation, but by the time you factor out that greatest common factor, you've got an equation that looks like x times x squared minus 6x plus 5 plus 5, and that's easy to do. You've got x minus 3, whoops, sorry, x minus 5, and x minus 1 for your so we've got zeros at 0 and 5 and 1, and a table of values, and there you go. And number 15, the zeros are, this one I would expect you to be able to do easily, and so we're going to find f of x. I've got to find the a, but they gave me a bunch of points. And I've got zeros at negative 3, so x plus 3 is a factor. I've got another 0 at negative 1, so x plus 1 is a factor. And I've got a 0 at positive 1, so x minus 1 is a factor. I'm looking for the a. They also tell me that it passes through the point 0, negative 3. Love that. 0, negative 3. That means x is 0. So I can just add those and negative 3, and we're solving for a. So when x is 0, this is 3 times 1 times negative 1, so negative 3. Negative 3 divided by negative 3 means a is 1. That's so nice. So now all we have to do is multiply those together. So f of x equals x plus 3 times x plus 1 times x minus 1. But we know that this is x squared minus 1 because it was a difference of 2 squares. And that makes it a little easier to FOIL and see where we end up. You should end up with, where am I? X cubed minus 3x squared minus x minus 3. See if you did. That brings us, thank goodness, to the end of 8.5, that video. Homework for tonight, which I think is April 1st, is exercise 8.5 worksheets 1 and 2, and those are under topics where your assignments always are, using My School app. Then tomorrow, no video, you're looking at the textbook problems that go with this. Those are listed on My School app, but also 1 and 2, 10 through 44 even, 52 through 60 even, 60 through 90 even, then 91 through 108. I know this is long, and so don't complain. You have 2 days to do those. You might want to do half and upload and half the next, or upload them all at once. And by that time, I hope we will know more of what we're doing, and I look forward to seeing you in person, because this is not fun for me. See you later, and thank you.